This is a fan favorite right here. Everyone loves prime factorization. People do this differently. I like to use what they call factor trees. So let's look at that and then see if that helps you guys out. Okay, so prime factorization. A prime number is any number. It can't be divided by anything by 1 in itself in order to get whole values. And I'm sorry, they have to be whole values. So 30, let's start with 1. So 30, first, to start off our tree, we're just going to branch these out, okay? So I just want any two numbers. It doesn't matter what they are. I need two numbers that multiply together. That would give us 30. I'm sorry? 5 and 6 is great. Now, since we're choosing 5 and 6, it doesn't matter if you had chosen 3 and 10 or 2 and 15, okay? But we chose 5 and 6. Now, 5 is prime because it can't be divided any further, okay? But 6, we can split 6 up. What two numbers would multiply to give us 6? 2 and 3. Now, I don't care what order you put these in. It is possible that the computers may want this from least to greatest, but on the test, I don't care. These are all multiplied. The numbers that I have circled, if I multiplied those together, no matter what order I multiply them in, I would get 30. So it's really 5 times 2 times 3. That is our prime factorization. So 52. Now 52 is not as common a number as 30, but one thing we know is that it's even, okay? If it's even, we know that we can at least split this up with 2 in some number. And 2 is always prime, so that's nice. So really, we would want to take 52, and again, this is something I could do on a calculator, and divide it by 2. Bam, 26, right? 26 also is even, so I can split this up between 2, which is prime, and 13 in this case. 13, we could try to split this up, but the only way we could is with fractions or decimals. So, as it turns out, 13 is prime. And this is our prime factorization. 13 times 2 times 2. This looks like a big number. Now this is even, so we could split it up between 2 and some number. But we can see that it ends with a 0. So we should be able to multiply it by 10 and something else. In this case, 110 divided by 10 would give us 11. And 11 is prime, that's nice. So all we got to do is split up the 10. 5 and 2 or 2 and 5. Again, that order does not matter. 5 and 2 are prime, so this becomes 11 times 5 times 2. This skill is pretty crucial, especially once you get into 1010, if you take 1010. Because once we're looking at nonlinear functions, which again we don't have to worry about here, and we're starting to factor polynomials, this is pretty crucial, even though we hate it. All right, so 360, how do you guys want to divide this up? 2? So 2 is, again, yeah, that's nice because this is an even number, right? So we can divide it by 2. And when we do that, 360 divided by 2, which you can do on a calculator, would be 180. Now this one also is prime. I'm sorry, this one also is even. So we can split it up between 2 and something. 180 divided by 2, 90. Again, we have an even number, so we can split this up between 2. And now it's 45. 45, though, should split up a little bit different. Okay? 3 and 15. It's not what I was expecting, but it works. That's very good. 3 is prime. Was anyone thinking 9 and 5? Because that's what I was. That's what I had. But no, 3 and 15 is good, okay? So don't worry about that. 15, I get another 5 and 3 there. So, well, this one gave us six numbers, right? I got the 3 times the 5 times the 3. Then I've got these 3 2's. I'm using different colors. I mean, you don't have to, of course. But hopefully that helps. This one's really nice because it's not even. And most of the numbers we have dealt with so far have been. And that last number is not a 5, so we know it's not divisible by 5. It's not a 0, so it's not divisible by 10. So what other number could it be? I mean, it is possible that this could be prime, and we could say, you know what, this cannot be factored. But here's one thing we can do is there's a way to know that any number is divisible by 3. And in this case, the 3 digits that we have is 1, 5, and 3. If we add these numbers together and we find that that number is divisible by 3, then the number that we started with is divisible by 3. That kind of felt like it came out confusing. Is that okay?
Got it.
All right, so let's add these. 1 plus 5 plus 3 is 9. Well, that's a lot easier to tell if that's divisible by 3. Is 9 divisible by 3? Sure it is. So this means that we can take our 153 and factor out a 3, which is prime. That should give us 51. Now 51 is an interesting number because it looks prime. It's not even, it's not divisible by 10 or 5, but 5 plus 1 is 6, which is divisible by 3. And that would be 17. Well, 1 plus 7 is 8. That is not divisible by 3. And it's not divisible by 7, 2, 4, 6, any of those numbers. So 17, as it turns out, is prime. And the factorization would be 17 times 3 times 3, or 3 times 17 times 3. Again, the order to me is not important here, as long as we can factor that stuff out. So for all of these, it's really crucial to remember, we're really looking at that ones position. Is it 0? If it is, then it should be divisible by 10 or 5. If it's even, the ones position, then we know that it's divisible by 2. After that, we're really just looking to see if it's divisible by 5 or 3. If it's divisible by 5, it should end in 5. If it's divisible by 3, then we got to add the numbers, which is just a little bit different there.